folks. So here we are in Miss J's chemistry classroom again. We're going to talk through one of the IB mandatory practicals, which is how to find the molar mass of butane gas. This is one of the required practicals that all IB students do worldwide. So this fits perfectly into gas laws. It would be much easier if you could do it in the classroom with me here, but here we are doing it as a demo. I'm going to collect some data for you, and then you are going to process your data and write a conclusion. So the basic setup is this. Typical lighter is filled with butane fluid. It's at high pressure until I open up the valve. That increases the volume and it depressurizes the gas and turns the liquid into a gas. I have it in this jug of water here, so it becomes the same temperature internally as the water in this tank. I've got a graduated cylinder that I'm going to use here in a few seconds. I've got a temperature gauge, a thermometer that is hanging out here that is just taking the temperature of the classroom. I've got my triple beam balance that is going to give me the mass of the lighter. And I also have a barometer, a little vernier barometer hooked up to my computer. So here's the typical setup here. First and foremost, I write down that butane has the molecular formula of C4H10, 10 hydrogens and 4 carbons. I'm going to walk through the procedure that you will see on Schoology. First thing I'm going to do here is I'm going to pull my lighter out of the water and I'm going to dry it as much as possible. I'm going to tap it upside down so I get all the water out, and I'm definitely going to keep it nice and dry. I'm going to take its mass here and I'm going to take its mass, and I'm just going to ask you to trust me when I read this off for you. And all of this data is going to be located on Schoology for you. I find the mass of the lighter before I release some gas of 19.700 grams. You can write that down now if you so desire, but again, it's going to be listed in Schoology. So now I'm also going to tell you what the pressure is of the classroom, which is going to be the same as the pressure of the water inside of this tub and the pressure of the water inside the graduated cylinder. That is going to be 101.9 kilopascals. It's really close to sea level because sea level is 101.3 kilopascals. And I'm going to take the temperature of the room afterwards, and I'm going to take temperature of the water afterwards and see how close they are together. I want the water temperature and the temperature of the room to be as close to each other as possible. Okay, so I'm going to collect some gas now. In order to collect this gas, we're going to do the water displacement method. And I hope you can see this when I zoom this in. It's really similar to that lab that we did where we separated hydrogen and oxygen in water. And we did water replacement to get the hydrogen and oxygen gas. I'm going to fill up this graduated cylinder as full as possible so that there are hardly any air bubbles. Easier way to do that is just to fill it up with tap water, get it all the way up to the top. So here's my graduated cylinder. It's filled almost to the rim. I'm going to cover it with my hand, put my hand underneath the water, and I am going to let that sit for about 5 minutes. So I'm going to pause the video for 5 minutes, and then when I unpause it, you will be ready to move again. Okay, it's been 5 minutes, and now I'm ready to collect some gas. So what I'm going to do is I'm going to take this lighter, I'm going to stick it underneath the surface of the water, and this is going to be really difficult to see. You just have to trust me on it. when you push down on the red lever, maybe you can see this if you zoom in, butane gas is getting collected into the graduated cylinder, pushing out the water from the graduated cylinder. And I'm going to let this go for a bit until I have collected 80 milliliters of water, or of gas, displacing 80 milliliters of water. If you zoom in, you might be able to see the bubbles a little bit. I'm going to pause the video so you don't have to wait so long, but just know that the butane gas is pushing the water out of the graduated cylinder. Okay, so it's been 5 minutes. I've collected all of my gas. I hope you can see. I don't want to lift this above the lip of the tub, but there's the water level right there. And all of this is butane gas. And I have collected 81.5 milliliters of gas in there. And I'm going to adjust that a little bit because I am going to make sure that the water level in the tub matches the water level in the tube, because that's going to make sure that the pressures are equal to each other. And that adjusts down to about 81 milliliters. Again, all of this data is going to be in Schoology, but the volume of butane gas I collected was 81 milliliters. I'm also ready to take the temperature of the water, which is the same as the temperature of the classroom, which is 22.5 degrees Celsius. And I think I already mentioned to you that the pressure is 101.9 kPa. So the next thing I'm going to do in the next video is I'm going to talk you through some of these calculations and how to come up with the molar mass of butane gas at the school's room temperature.